already talked about what a linear relation is. And if the relation is in a table, the left column goes up by the same amount or down. The right column goes up by the same amount or down. Doesn't necessarily have to be the same as the first column. That makes it linear. On a graph, it's pretty straightforward. If you can draw a line through it, or if it's a line, it's a linear relation. Okay. Now we're going to extend that to linear functions. Okay, which is actually something that you should be able to figure out. Like, for example, here we have a graph. We've got time and we've got temperature. So when we start to measure, the temperature is -5 because the vertical column is going up and down by 5s. And then the temperature slowly increases until after 12 hours we stop and the temperature is 10 degrees. Is that linear? Guys, that should be a straightforward question. Why? Because it forms a line. Exactly. Okay. Now, we've talked about this earlier in the unit. Is it a function? Yes. Why? Yeah, I'm hearing it. Yes, because domain never repeats. Or, remember we talked about something called the vertical line test. Can't draw a vertical line through more than one point. That's another way you could explain it if you want. Okay. So because it's linear and because it's a function, we can call it a function. And how we would say it is we would say we can describe it as the temperature as a function of time. Something that we've already done, how to find the domain and range. What's the domain of this function? Remember, domain is left to right, left x value to right x value. 0 to 12. So we can write it in integral notation with brackets because we include the 0 and 12. Or if we use the other notation with less than or equal to signs, we would say 0 less than or equal to not x, but t less than or equal to 12. Those two mean the same thing. Okay, now range, lowest y to highest y. Well, lowest y is? Highest y is? Right? So we go from -5 to 10, and we use that integral notation. Or if we use the other notation, we'd say it's between -5, it's capital T, not y, and 10. We already answered this question. Yes, because graph forms a line. And is a function.
Okay, rate of change. Remember, rate of change, the formula for rate of change, and I'll just go to ROC, is the same as the slope formula. So a second y point minus first y point over a second x point minus the first x point.
Question.
Sure.
Why is it?
We always say that the dependent variable or the vertical is a function of the independent. Like it depends on, the temperature depends on the time. Yeah.
So to find the rate of change, I need 2 points.
Well, we got 4 points.
We could use this one, which is 0, -5, and this one, which is 4, 0. So we would subtract 0 minus 5 divided by 4 minus 0. Sorry, 0 minus -5. So it's 0 minus -5 over 4 minus 0, which is 5/4.
And with rate of change,
We always want to go to decimal.
it usually makes more sense.
So you can just divide this on your calculator, and you get 1.25.
What are the units?
So this per hour.
3 Celsius per hour. So what does it mean? The temperature goes up 1.25 degrees Celsius per hour. Okay.
Two other things that we can talk about linear functions. And we've done these before.
We just use different names.
The horizontal intercept and the vertical intercept.
Well, the horizontal intercept, remember horizontal is x-axis. So the horizontal is the same as the x-intercept. Or it's the x value when y is equal to 0.
So on that graph, what's the x value when y is 0? What's the x value when y is 0? Come on, guys. Here's where y is 0. What's the x value? 4.
So the horizontal intercept is 4.
That's it.
The vertical intercept, that's the same as the y-intercept. So that's the y value when x is 0. What's the vertical intercept of our example?
On the graph. What's the y value when x is 0? -5. That's it. Okay. All right, let's do some examples. So we've got a graph. that represents the volume of gas in a scooter. So obviously,
When you don't travel anywhere, your volume is at its highest, and then as soon as you travel, it goes down to nothing. We want to find the horizontal and vertical intercepts, which we can read right off the graph.
what value does this graph hit the horizontal axis? 200.
What value does this graph hit the vertical axis? 8. So 200. 8. Domain range. Well, domain left X
To right X.
0 to 200. And we put brackets. Range is lowest Y to highest Y, 0 to 8. And remember, you could answer in the other location. So we could say 0 is less than or equal to, it's called D instead of X this time, for 200. And for this, it's 0 is less than or equal to capital B instead of Y.
You don't have to write both of them. Okay, that's why I say or.
Most students like integral notation.
I find it easier to work with.
And finally, the rate of change. Well, remember, we need 2 points. Well, let's use these 2 points. What point is this? What coordinate is this? 0, 8. And this is 200, 0. So let's do second Y minus first Y over second X minus first X. So we get 0 minus 8 over 200 minus 0. That gives us negative 8 over 200. Let's convert that to a decimal. And we should get negative 0.04.
Units.
Remember, vertical volume per distance, per kilometer. So the volume is liters per, what was the time again? Or sorry, liters per kilometer.
And what does it mean?
Okay, how can we say this? The gas decreases or goes down at, we don't put the negative in because we've already used the word decreases. 0.04 liters per kilometer. Okay. Okay. This one,
You're asked to graph.
remember we talked about this earlier in the unit. F of X means the same as what letter? Y. So think this is the same as Y equals negative 2X plus 6. And we have done a ton of these.
How did we graph it? Well, we used a table of values, which wasn't great. We used intercepts.
We used y equals mx plus b, which is usually a good one to use. M is the slope, b is the y-intercept. So what's the y-intercept of this equation?
6,
6. And the slope?
-2,
-2. And we want it rise over run, so we toss it over 1. So we plot the y-intercept of 6. And then from the y-intercept, the slope tells us to go down 2 and to the right 1. So 1, 2, 1. Draw your line.
That's it. Okay. For the next example, we have a couple linear relations, or actually linear functions. Which one has a rate of change of 1/2 and a vertical intercept of 6? Which one of the two?
Well, where does this one get the y-axis? What's that? 6. How about this one? So that doesn't help us. What about rate of change, which is the same as slope? Well, how do I get from this point to this point? I go up, down,
down to
down 1, which is negative, and to the right 2. So this is a rate of change of -1/2, which means this is not it. I want +1/2. This one goes up 1 to the right 2. So this is the one. Okay? So this is the one. Because this one has a rate of change of -1/2. So that means it's out.
Okay, the last example.
This sort of brings everything together. These are the kind of questions that we want to answer using linear functions. Okay? So we've got a graph showing the number of yearbooks on the x-axis, called n, and the cost of the yearbooks, or capital C. So we see that if you printed 0 yearbooks, how much is it going to cost you? How much is that?
500.
$500.
So if you don't print any yearbooks, it's going to cost you $500.
If they print 50, it's going to cost 1,500, etc. We want to find how many yearbooks does it cost $4,200? Well, 4,200 is somewhere in here. Or sorry, somewhere in here, but I don't know exactly where.
So I can't just really use the graph.
I know it's going to be, well, this is 175.
It's probably going to be a little more than 175. But I need to be exact.
Okay. So I know it's somewhere here, but I don't know
What that n is. So what we have to do is we have to make the equation.
and then use algebra. Remember in the last lesson, to make an equation out of this, you take the dependent variable equals whatever the rate of change is times the independent variable oh, here. Plus the initial amount. And really, the initial amount is the y-intercept.
Well, the dependent variable, that's the vertical one. What letter is represented by the dependent variable in this graph?
It's y, but in this case, capital C.
Rate of change, I have to calculate.
And remember, so we're going to have to calculate by going y2 minus y1 over x2 minus x1. So I need 2 points. Well, here's 2 points, 0, 500, and 50, 1,500. So find the slope of those two by taking the second y minus the first y over the second x minus the first x. So it's going to be 1,500 minus 500 over 50 minus 0, which is 1,000 over 50, which is 20.
So the rate of change is 20.
And that's what we want. The independent variable is just a letter. It's the letter on the x-axis. In this case, what letter? N. Plus,
What's the y-intercept?
500. So our equation, I'll just clean it up a little bit here, is C, the cost, is going to be 20 times however many number of yearbooks
Plus 500. That's how you figure out the equation. Okay?
So now I can use this. What cost am I told? 4,200. And I need to figure out what N is.
So you need to solve that equation.
What do I do? Subtract 500. You guys are good at this. And then plug it in. Divide by 20. Divide by 20. And the number of yearbooks,
Sorry?
185.
Which we said it was over 175, so we were close, but this is exact.
Okay?
Okay, that wraps up
Unit 5.